Alright, welcome back. Today we'll be discussing definite integrals. This is a quick introductory video to this topic. So this is just the notation, that's I guess what we'll start with, of integrals. And integrals are very similar to finding area under a curve, but it's not exactly the same because integrals can be negative, whereas areas cannot. So this is the basic notation of an integral. You have a function and you're taking the integral of it on an interval from a to b, like that. That's the interval a to b. And this actually equals the antiderivative of, so this equals where this capital F is actually the antiderivative of this function f. So it's the antiderivative on any antiderivative on this interval a to b. And so you take it and you substitute this value in here and the a value into there. So to do a quick visual of this, if you have a sine curve, right, and it looks something like this from 0 to 2 pi, the integral of from 0 to 2 pi of sine x dx is equal to 0 because this area here matches this area here, and in the end they cancel each other out and you get 0. But if you were to find the area under the curve from 0 to 2 pi, it would be a different story. It'll be a positive number and it won't be 0. So that's pretty much the integrals conceptually. Let's try a few examples. So the first one we'll start with will be a simple example. So again, integrals, the thing to remember is the antiderivative, and you're inputting the values. It's the antiderivative, and you're inputting the values that are along the interval on the antiderivative. So let's just do an example to see how this works. So if you have an integral from -1 to +1 of r plus 1 squared dr, right? This would equal, now the antiderivative of this will be r plus 1 cubed times 1/3. You can see this, you'll be quicker at this as you go along in doing this, because you can see that if you were to take the derivative of this, you'll actually get this, and you'll do this from the from -1 to 1. This is actually just another way of writing what's up over here. It's just the same notation. So actually, we'll go ahead and we'll write it like this. So it actually equals 1/3 1 plus 1 cubed minus 1/3 -1 plus 1 cubed. So this is the antiderivative with the value of 1 minus the antiderivative with the value of -1. So this is again b, and that's a. And you get over here 2 cubed is 8, so 8/3 minus that's 0. So the answer is just in the end 8/3. So let's try another example. This time let's do one with some trig functions. So let's take the integral from 0 to pi/3 of 2 secant squared theta d theta. So the antiderivative, or the integral of this, would be 2 tangent theta, because the derivative of tangent theta is secant squared theta, and if you have a constant, you know the rules of differentiation, and just multiplies in there. So 2 tangent theta from 0 to pi/3. So this is b, and that's a, and then you can just take the, you have to subtract the 2, so you have to do Again, remember it's f, the capital F, which is the antiderivative, minus that. So this is just a reminder of what we're actually doing. And so 2 tangent pi over 3 minus 2 tangent of 0. And tangent of pi over 3 is square root of 3. So this is just 2 square root of 3. And that's, again, 0. So the answer here is 2 square root of 3. That's pretty much integrals.